Alright, I'm going to explain to you rectangular, polar, and parametric and their relation. First, I'm going to talk about rectangular graphing, which you should already be familiar with. Alright, I'm going to be graphing the function y equals 2x plus 1. Now, we have our axis. Alright, so we have our axis. Now, we plug in what we want to find into the x coordinate we want to find, and then we get the y out of it. So, we plug in 0 for x, and we get 1. So we know the point is 0, 1. This is stuff you should already know. Alright, and then 1, I get 3. So, I do that. And then, let's just say I want to do negative, so I'll do -1, and I get -1. So, I put that there, and we have our line. As so. Now, I'm going to be talking about parametric graphing. Now, parametric graphing, the first thing you have to do is turn a rectangular function into a parametric function. Now, there are a few different ways to do this, but the first way I'm going to do this is the easiest, to show you how. Now, you have to replace one of the variables with t. Now, in this equation, it's a lot easier to do it with x. So you have two functions. You have the y equals function, and you have the x equals function. So x is going to equal t. So all you have to do there is take that function and put t in for x. So we have 2t plus 1. Now, with parametric graphing, we have to put in values for t to find the x and y positions. Now I'm going to start at 0 again. So when t equals 0, x equals 0. So we have our x. And then put 0 in for t in the y parametric equation, and you get 1. So you have 0, 1. Now, it's starting to look familiar. Now, you put in 1 for t, and you get x equals 1. And put 1 in for y, and you get 3. So, 1, 3. Now, go for -1 in t, and you get x equals -1, and then y equals -1. So you got your line again. Now, that's very much like the rectangular, because it is. Okay, so now I'm going to talk about other equations. Alright, so now we're going to convert this rectangular function into a parametric Alright, so now we're going to convert this rectangular function into a set of parametric equations. Now, it doesn't look a lot more difficult, and it's not. You still do the same thing. You have to pick one of the variables with t. In this one, it's also a lot more easier to put x as t. So we have x equals t in this parametric equation, and then we just put in t where x is in the y equation for the rectangular. So we have t squared plus 3. Alright, now I'll graph them side by side and see if the graphing is the same again. Alright, so we have a rectangular and our parametric. Now first, I'll graph the rectangular. This is just a parabola that is raised up 3 from the axis. So I have 0 for x, which means I have y is 3. So let's put 3 here, and then we have just a parabola, so it goes like that. Alright, now for parametric, I put in 0 for t, which means 0, x is 0, and then 0 in for t and y, which we get 3 again. Alright, so now I put in 1 for t, and I get 1 and then 4 for y, so right here. And then -1 for t, and I get 4 again, but on the other side. Now, just to make sure, I'll put in 2, and we get 7 for y. So that's definitely a parabola. So as you can see, the rectangular and the parametric equations are the exact same graph. Okay, so in polar, a coordinate has 2 points, but not like rectangular and parametric with x and y. Polar has r and theta. R represents how far from the origin it is, or the radius, and then theta represents the angle of the equation you're graphing. In polar, sine goes with the vertical axis, and cosine goes with the horizontal axis, just like when you find the cosine and sine of points on the unit circle. The cosine is the x-coordinate, and the sine will be the y-coordinate. So now, I'm going to talk about polar graphing. So for converting to polar, I'm going to use our old example of y equals 2x plus 1. Now like I said, cosine is going to go with x, and sine is going to go with y. So we need to convert this into polar. So we replace y with r times sine theta, and then x with r times cosine theta. So now you should have this equation, r times sine theta equals 2 times r cosine theta plus 1. Now, what we want to do is get our r's on the one side, because in a polar equation, it's r equals blah, 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 blah. So we have to take this and put it on this side, and we'll do that by subtracting 2r cosine theta to this side. So now you should have this. Now we want to take r out of that, so we can get these things to the other side and have r equals blah, 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 blah. So I'll do that now. Now I erased my board, but now you should have this. Now all we need to do, all that's left, is to take this sine theta minus 2 cosine theta and move it over to the other side by dividing it from here. So what you end up with is r equals 1 over sine theta minus 2 cosine theta. And now that is your polar equation for the line that we made with y equals 2x plus 1. Now, let's get some more polar practice in with this equation for a circle. So let's convert this rectangular equation for a circle into a polar equation for a circle. Now, it's the same thing with y equals r sine theta and x equals r sine theta. So we put r sine theta into where y was, so we have r sine theta squared. And the same thing with x and r cosine theta, so we get r cosine theta squared, and then equals 4, which doesn't change from the rectangular equation. So now we want to multiply this out and get our full equation, so we can start messing with the r's and get it all sorted out. So this is what you should have after squaring everything out. R squared times sine theta squared plus r squared times cosine theta squared equals 4. Now we want to get r by itself and take it out of the cosine and sine. Okay, so you've pulled the r out. So you pull the r out of this equation and you get this. You get r squared, and then in parentheses, sine theta squared plus cosine theta squared, and then equals 4. So now we want to move this all the way over there by dividing. Okay, so you've taken this, and then you divide it over, and you get that. Now there's one last thing to do. We have to get it r equals, so we have to take the square root of both sides. So I'm going to do that now. Okay, so you have this. Now we have to take the square root. So we take the square root of r squared, and then of the other side of 4 over cosine theta squared plus sine theta squared. So now that knocks the squared off the r, and it bumps 4 to 2 because 2 is the square root of 4. So we have r equals 2 over the square root of cosine theta squared plus sine theta squared. And that is your polar equation for your circle.